Today's lecture will talk about the meteorology and wind measurements. As you would recall, the meteorology is the one which affects the transport and dispersion of the pollutants, and wind is a primary mover for the transport of the pollutants, and wind speed decides how quickly the pollutants will disperse, and wind direction decides in which direction the pollutants will go. So to come to the wind measurements, we have to go through some basics about the energy and to say why does the wind blow at all. Essentially, the reason for the wind to blow is the difference or the unequal heating of the earth's surface, and so there is a temperature difference and there is a pressure difference, and wind would always travel from an area from high pressure to the low pressure. So it's essentially the energy which reaches earth that decides the heating part. So we'll go through some basics. As you can see here in the slide, the energy is transferred through the three mechanisms which we all have studied in our high schools: the radiation, conduction and convection. When we talked about the air pollution or the movement of the pollutants on the earth, it is largely the convective currents that decides the dispersion of the pollutants, because that the convections occur at the ground surface. The ground gets heated, as you can see, and the hot air or the warm air goes up, as you can see on the picture on the left hand side, and the cool air comes in. So it's kind of the convective currents which are passed, and that's the primary reason for the transport of the pollutants. You can also say, again, you can see the convection is important phenomena in the air pollution meteorology, and with this convection the wind blows and the wind direction decides where the pollutants will go. What are the factors which are affecting the wind with the energy balance, and then also that could also affect the wind pattern and the wind speed, wind direction, etc. And so that the ground cover, as what kind of surface is there, it is a snow surface or the water surface or the plain ground, or it is a desert, or it's a land covered with the vegetation, and then the cloud cover, how much the cloud is there in the sky, that decides as to how much heat or how much energy will come onto their surface. There are certain gases, the greenhouse gases, which you can see here is the gases which decides as to how much will be the pollutants or the heat would be trapped, okay, and then that may cause the warming of the atmosphere, and also the pollution, which are largely the aerosols which can absorb the heat. So these are all the factors which decides as to how much is the amount of the energy that would reach and would be stored into the earth system. If you take a little bigger picture and see the role of clouds here, so you can see here the heat is, or the energy is coming from the radiation, but there are two types of cloud that we will talk here. First is the high clouds, which are thin, for example, and there is another clouds which you can see here with my, as I am ticking mark, is the low clouds, but with the thick clouds. So what happens is the energy as it comes onto the surface, okay, some portion is reflected back to the space again, and the solar radiation which is coming here are the short wave radiation. When short wave means the wavelength of the radiation is very, very small, it's in the nanometers or micrometers, and we'll see why it is so. And the part of the energy which is coming here is reflected back, okay, and the part of the energy is reflected or given out in the form of the ongoing long wave radiation. See, what is coming here is the short wave, okay, and the red thing what you are seeing here is the long wave. Long wave comes because once earth get heated up, it starts emitting the heat energy. Okay, so we have to look at the total balance, and once this heat energy go up, part of this would be reflected back, as you can see here in the system, and part may go back to the space. And same thing if you look at the thick cloud, most of the things here, you see the thickness of the arrow here, most of the things are reflected, okay, and there is small amount reaches onto the surface, okay. And similarly the ongoing long wave radiation, as you see here, part of it will go through the space and part of this one will come back to the ground. So that is you can see the cloud play a very important role, and we will see what it means in terms of the heating and cooling. And before we go, we also need to understand one more terminology, is called the albedo. What is albedo? Is a radiation is not only emitted, absorbed, transferred, but also reflected. The terminology here important here is the reflection of the energy. The albedo of a surface, which is the surface specific, is the reflectivity, how much would be immediately reflected, or the ratio of the radiation that is reflected to which hits the surface, the amount of the radiation that is hitting the surface, and what fraction and part of that radiation will be reflected, that we refer to as the albedo. So the sum of the albedos of many surfaces on the earth are important in determining the earth's energy balance. So it's not only the absorption, it's not only the long wave radiation or the short wave radiation, role played by the ground, role played by the clouds or aerosol, but it is the reflectivity of the surface or albedo that is also very important. To give you a little feel as to what surface gives what kind of albedo is, that you can see here. For example, look at the snow, okay. As you will understand, the reflection from the snow surface is very high, so 79 to 95. And similarly you can see, okay, when something is asphalt, okay, that's our road surface, okay, the most of this is black in color, so most of the energy will be absorbed here. So reflection from the black surface will be very minimal. So albedo effect from the dark black surfaces will be low, whereas the surfaces like snow, which is white in color, the albedo effect will be very large. So even that decides about the wind and the temperature and local wind conditions. So this is just the basic things which we need to understand, but we will come back to something to give you the understanding of the short wave and the long wave radiation. As we said last time, we showed that when the radiation that is coming from sun, they are mostly in the short wave range, okay. And what range here you are seeing is 0.4, 0.8, 1.2, okay, is the nanometer of the wavelength, and this the sun's, and as the temperature of the sun is taken as 577 Kelvin, and the wavelength which will have the maximum energy, okay, that can be found out from this equation. And just remember that this lambda here is in nanometer, okay. So you get something like here close to 0.5 nanometer, where the peak in terms of the energy. When we come to the earth's temperature is low, okay, so the radiation from the earth will be in the long wave, as you can see here, and see the difference in the wave versus 0.8 here, that could be 10, 30, 40. So you can also estimate as to at the what wavelength the maximum radiation that will occur from the earth. So now the concept must be clear as to from the earth, most of the radiation that comes in the short wave form, because the earth's the radiation that is coming from the sun, that is in the short wave form, because of the sun acts as a black body and the temperature is very high, and the radiation that comes by virtue of heating of the earth, which is at the lower temperature, something close to 300 Kelvin, the radiations will be in the long wave. Okay, what it really means in terms of the hot weather and the cold weather. And now you can see here the day and night, clouds both reflect and release the radiations efficiently, as a point number 1. Short wave radiation from the sun is efficiently reflected, and long wave radiation from the earth is efficiently absorbed and emitted by the clouds. So what we see here is that long wave radiation from the earth is efficiently absorbed and emitted by the clouds, okay. High and thin clouds. So we will talk about two clouds. High and thin clouds radiate heat in the long wave radiation back towards the earth, okay, whereas usually the thicker clouds reflect incoming sunlight, okay, but also absorbs the emit heat from the surface. So, what it really means here, okay, that when the solar radiation is coming in, okay, it can reflect very efficiently, but then it can also absorb the heat, okay. And then what it really means in terms of day and night, in the daytime you will see that why is it this in the summer very cloudy days seems cooler, because when the days are cloudy, okay, the solar radiation is stopped, okay, and then in the night time, if it is a cloudy, then of course there is no radiation that is coming in, but what you can see is that whatever the radiation absorbed by the clouds is reflected back, okay, in the night time, okay. So, you can see in the if you have the cloudy nights, then the temperature will be little higher, and if you have the cloudy day, the temperatures will be somewhat lower. So, this is the studies about the temperature, but the focus of this lecture is really about the wind system. In the measurements of the wind, there are two important things. One is the direction, okay, and one is another is the speed. Okay, then we will try to understand and you must have seen this picture as on your left hand side, which is a very common picture on the television you must have seen. So, this is it is showing the direction of the wind for the arrow, okay, and the direction of the wind is measured in terms of the north, east, west and south, and we will see, we will go on to the more details as to see what are the other directions in which the wind can blow and how this is classified. What is the important thing to see in this figure on your right hand side, okay, is suppose this is my north direction and my wind is blowing from this direction, and this direction will be east, okay, and this is what is a pollutant source. So, the wind will transport the pollutant in the direction opposite to the wind direction. So, this will be the area that may be affected because of air pollution. But let us understand that how these wind are measured and how we represent the wind system, so that we understand it better. What is the important thing to understand here is the wind blowing from east, that is 90 degree. I will explain in a moment the 90 degree, but one concept that is important, and we will discuss this concept a little later also. The wind direction is the direction from which wind is blowing. Sometimes it is a little unusual or improper concept people have. They think the direction in which the wind is going is taken as the wind direction. That is not correct. The direction from where the wind is coming is taken as a wind direction. For example, in this figure you say wind direction is east, right? It means wind is coming from the east. We can also say, if I want to show in the degrees, that I will explain a little later, the wind direction is 90 degrees, okay, that we will see what it really 90 degree means. But this concept is important, that wind direction, it refers to the direction from which wind is coming. Okay, now I will give you some more concept as to how the wind direction is understood in a more slightly complicated way, because direction can be like, you can say the wind direction could be really be infinite basically, but still there are ways the people have evolved or scientists have evolved to show the wind direction. So, first of all let's consider the example where we understand that example very easy, and what I am drawing here now is the 4 wind direction that we all understand very well. So, let us see what are those 4 directions. You can see here north, okay, you can see east, you can see south, and you can see the west, okay. And suppose this is same as measuring the angle basically. So, suppose I am going in the clockwise direction, okay, and I start measuring the angles. So, suppose I am starting with 0 angle, that I am calling as north. At east the angle of the will be 90 degrees, and south it will be 180 degrees, and the west it will be 270 degrees. Let us remove this, okay. However, just giving the 4 directions is not enough, because as I said there could be many wind directions. Scientists, what they have done is they normally expect at least 16 wind direction is considered. So what we can do is that the blue circle, that what you are seeing, I can divide this into 16 equal parts, and then that is what I can give the 16 different names to the wind directions. So let's do that. So what I'm going to do is I'll divide the blue circle that you see here in the 16 equal parts. 1, 2, 3, 4, 5, 6, and you see that you'll find here the whole circle is divided into 16 equal parts. We can quickly even check if you like. This is 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and 16. Okay, so you know what we have done is we have divided this thing in 16 parts, and now what we will do is that try to give the names, okay, to these parts, and also we can define the angle, and that would decide, and that would tell me that what wind direction is. So let's give some names to it, and what you can see is that certain names are given to these 16 directions. Okay, do you understand north, east, south and west? But the first part, the wind is from the first part of this one, is called north, northeast. Similarly, the wind which is this direction is called northeast, east, northeast, this we have discussed, east, southeast, southeast, south, southeast. Why it is called south, southeast is basically this is, or in other words I should really be saying it, south of southeast. Okay, so this is southeast and this is the south of the southeast, so this is called the south, southeast, and this is the south of southwest, so this is called south, southwest. Okay, southwest, west, west, southwest, west, west, northwest, northwest and north, northwest. These are the names that we give to the various wind direction. Simple. But as I said, I can also give the names or the wind direction. I can also measure not only north, northeast, south, southeast and all. I can also measure, and which is probably even better is to represent the wind direction by the degrees. Then I can precisely pinpoint where the wind is blowing from. So let's give them the okay. What is this angle this is making? That this angle is, as you can see here, is 22.5 degrees. So basically this if my wind direction, I can also say 22.5, this will become 45, okay, and this will become 67.5, or basically it will become 68. Now this will become 67.5, and then this will become 90. So we can even give the degrees if you like. Okay, okay. So we can exactly say, if you know the exact degree, then we can think and we can imagine where the wind is coming from. But for quick understanding, normally wind is presented in the direction either it is north, northeast, northeast, east, northeast, etc. So let's remove this. Okay, and then what we would do now in this one is, when I want to say my wind is from north, okay, what it really means in terms of the what degrees will occupy the north direction. It means if my wind is halfway in between here and halfway in between here, and the wind is blowing anywhere from here to here, okay, that is what I want to call as the north direction. So this angle basically this angle will be the half of 22 and this angle also will be equal to half of 22. So, let us divide this, so we can clearly shows what range of degrees would refer to as the wind direction or the north direction. So, let us do that. Okay, what we are seeing here is that if I have to, what degrees will represent the north direction. So, essentially what I should do is that divide this part in half and divide this part in half, and let us do that one. So, what I have done, I have divided this angle between north and north northeast by half degree, divided or bisected this angle, and I also bisected the angle which is north and north northwest. So, if I measure this angle, how much would that be? This will be 11 and quarter. Let's say so 11 and quarter degrees is the angle. So, what should be the my wind direction? Suppose my wind direction is between. Okay, so I can subtract 11 and quarter from 360. So, this becomes 350 and 349 and 349 348.75, or let us say if the wind direction is between 348 3 by 4 to 11 and quarter. Let us write it 11 and quarter degrees, and let us write degrees here. It means it implies wind direction is north. Why? Because this angle, the measurement on my this circle is basically this angle. Okay, this angle starting from 348 and 3 quarter and going all the way to 11 and quarter. So, that way I can find out, once I have the degrees, I can find out what direction the wind is blowing from. So, and then similarly we can do at different places where I can divide this into equal parts, and then this angle I can, half of this I can bisect. So, this thing, if as long as wind is blowing from this sector, I would call that wind direction is east, or essentially I will take that wind direction is east, and in degrees it will be 90 degrees. Okay. Okay, the important concept which we said in the earlier, and again we want to repeat, is what is wind direction? Wind direction is a direction from which wind is blowing. That's very important concept. So, if I say wind direction is northeast, it means the wind is coming from northeast, or in other words, if I say wind direction is 45 degrees, it means the wind is coming from northeast. If I say wind direction is 180 degrees, it means wind is coming from south. Okay, that's very important concept. Okay, let's do one more example or question. The question is, as you can see at the bottom of your screen, is what is the wind direction if the measurement shows this as 78 degrees. Okay, so 78 degrees, where would that be? Okay, so if I say here, if I divide this in the equal parts, so this will be how much? 90 minus 11.25. So, this will become 80 and 79 3 quarter. Okay, and what is my actual wind direction is 78. So, it is somewhere here. So, my wind direction is like this. So, I divide this into the half part here. So, this is where in this sector the wind is blowing. So, it means my wind direction is essentially in a summary fashion is east northeast. Okay. So, that essentially depending on the degree of wind direction you have, you can convert this into the whether it will be northeast or east northeast or south or east southeast. So, that should be a simple thing once you have understood the things. Let's go to the next slide. What you are seeing here is, now we are talking about the measurements. Okay, what you see on your screen is a photograph of a wind measurement system. Okay, this side, okay, I'll circle that, okay, is the called a wind anemometer. Okay, and then this thing measures wind speed. Okay, and this thing what you see on this one is called wind vane. Okay, and this what it measures is the wind direction. Okay, now we have to see, basically we should know at least, although I mean we don't manufacture ourselves the things as the experts who are doing this one, but we should at least know the underlying principles as to how the wind speed is measured. In wind monitors, anemometer, that is a device that is measuring the wind speed. The shaft, you can see here, the shaft is somewhere here. The shaft rotation is sensed by a non-contact photochopper. Okay, photochopper assembly which develops a train of pulses whose frequency is proportional to the anemometer rounds per minute and therefore wind speed. So what happens is the photochopper placed inside this one, the shaft moves, and because of the movement of the shaft, the shaft completes one round, the photochopper chops the photo, and that pulse is taken up by the microprocessor, and then this is correlated with the wind speed. So the microprocessor system counts, as you can see here, the microprocessor system counts the number of pulses received from the anemometer and performs the necessary division to give the wind speed in kilometers per hour. So mostly the units for the wind speed measurements are normally either meters per second or kilometer per hour. Both units are commonly used. Okay, and wind speed and wind direction system is there, and this little, although this is the vane, this little tip, this is actually this is a little pointed. Okay, and this is what is showing the direction. So wind is essentially blowing in this direction. Okay, so that's how you can find out the wind direction this way. Let's also see some more different other kinds of wind measurement system. Okay, this measurement system, as you can see here, there is only one shaft. Okay, and this is again some kind of anemometer that you can see, and this is a wind vane. So on one shaft itself, both the things can be installed, and you can measure both wind speed and wind direction. Let's go to another type of system that you can see here. Is that you see here, this is a three component of the wind speeds it can give. Okay, so again this is anemometer. Okay, direction 1, direction 2, and this will give us a direction 3. Or if you want to understand, this might be a good idea to put it like this. So wind will have three components. That is a U, that is the wind direction that you see as it is going like this. There may be small wind in this direction as well. Okay, this we call as V. Okay, or the another name to this one is the cross wind direction. Cross wind, how much is the wind perpendicular to the main wind flow. And we also, it's sometimes useful and interesting to measure the vertical component of the wind. That is what we sometimes refer to as W. That is what is the direction of the what is the speed of the wind in the direction, the vertical direction, and you can think of that this vertical direction can be upward, and don't be mistaken that it can also be the downward. So, in fact, we can, if it is sometimes a matter of interest for us that we want to find out all the three wind components, whereas a U is a predominant horizontal wind direction, okay, and that's sometimes more important than the other wind directions or the wind speed measured in the other direction, because this is my mean wind direction in which the pollutants will be transported. If that is clear, let us go to how the plots are seen. Nowadays, of course, we have the computers to do most of the computing to us, but the earlier time the wind direction were really recorded on the chart paper, as you can see here. And then here you can see what both the charts are showing the wind direction. Okay. Here the wind is changing very fast, you can see here. Or I should rather say wind direction. Changing very fast. Here wind direction is stable. Okay. Okay, probably it is still not clear to you that how it is recorded. So what we would do is that we will manually develop and show you as to how this is really seen, because this picture is not very clear. So generally what is there is a chart, okay, and this chart is written in terms of degrees. Okay, this can be 0 degrees, this could be 90 degrees, this could be 180 degrees, and this could be 270. It could be somewhere, it could be 270, and here is something like 360 or something. Okay, so what happens as the wind direction changes? Okay, and we can write, okay, we normally write this like 8 a.m. starting point, let's say, and we are measuring this on 5th of June. Okay, and this chart really moves, and the pen keeps on writing as you can see. So what you can say, and suppose this time, okay, this was 9 a.m., this was 10 a.m., and this was 11 a.m. So what it is basically, I have reproduced the same chart here with a little bit more clarity. So in the morning 9 o'clock the wind direction was about 90 degrees. Okay, at 10 o'clock the wind direction was still 90 degrees, but between 10 to 11 the wind direction was something like 270 degrees. So this chart one can manually read, but nowadays we have all the computers to do all the calculation and reading part, because now we are producing the micro signals, and that signals can be read and can also be stored. So but then essentially earlier times when we didn't have the so powerful and strong computers, so essentially everything was done manually. So similarly this was the wind direction chart. You can also have, or we used to have, wind speed charts. I will quickly go through the wind speed chart. Nothing very fancy about it, but something similar. But here in place of the directions we keep the speed 5, let's say 10, 15 and 20. the units may be kilometer per hour. Same thing you write here, 8 a.m. 5th of June, and then you can measure the speed. And you can find out at different time intervals on different dates what was the speed. And that two things which are important for us was the wind speed and wind direction, and we both, one can measure it and one can utilize in some of the systems in which you want to track the movement of the pollutants. This is a little graph or picture you see here that is showing the wind speed, okay, and the effect of wind speed on the concentration. Imagine that there is a chimney which are identical here, here and here, okay, and here the wind speed is very high, okay. What is the range of the wind speed which we are talking here? 6 meters per second. And suppose the wind speed was reduced, okay, and the wind was only 2 meters per second, okay, and you can see here the pollutants will travel fast, so the concentration, okay, will be smaller here, because you see here there are 3 parcels of the pollutants are still in this region, okay, in this region, okay, but because of the high wind speed, pollutants are dispersing away and they are moving away. So there is only one parcel of the equal mass is there. So normally we consider the concentration of the pollutant is inversely proportional to the wind speed. That's a very important concept, and that we'll use it later in our succeeding lectures. So this is very important, that speed can directly cause the decrement in the concentration. And wind direction we have already seen, we know the which place or which location the pollutants will have the impact on. With this concept, there is another concept which we want to discuss, is the calm conditions. You must be wondering as to what is calm condition, because we always have the wind, but there are certain conditions which we call as a calm condition. So calm conditions are there when the wind speed, which I am representing as u, when it is less than 0.5 meters per second, that we call as a calm conditions. It means wind is blowing, but it is very calm because wind speed is very, very low. Not that we can't measure the low wind speed, but it is a matter of convention, and there is a reason as to why we want to call this wind speed, which is less than 0.5 meters per second, to be as a calm wind speed or the calm conditions. What is the importance of the calm conditions? First thing, you can since you have now little concept of dispersion, it will cause very poor dispersion. Okay, if in a location where you live and suppose the wind is most of the time calm, most of the wind is 0.5 meters per second, then it means there is a likelihood or more chances of pollutants getting accumulated and concentrations going very, very high. So that is one thing it immediately tells us, that areas where the conditions or the calm conditions are more, we should try to avoid having the large industries or most of the pollution sources. The second important point about this is, when the conditions are calm, it also implies, okay, it also implies that wind has no definite direction. Okay, it means the direction changes from place to place, and that also is a very troublesome situation. And then I'll show you as to why it's a difficult situation. We have the calm conditions, and when wind direction is not constant, it is really changing, and it is really changing from place to place within a short time. And to give a little this concept to you, the point number 2 which I was referring to. Okay, let's say if the wind was calm, suppose this is your city, and you have a source, a pollutant source or a chimney or a power plant or something at this point. Because now what happens when the wind speed is low, 0.5 meters per second, it may have some direction of the wind, okay, but this direction, the moment I go at different location, for example, I go and measure the direction here, the direction as well might be like this. Within a short distance in a city, let us say within 1 kilometer or half a kilometer, you can see the wind direction can change. If I go here, okay, wind direction, it might see that wind direction is like this, okay. If I go here, wind direction may be like this. If I go here, wind direction may be like this, okay. So wind vector or the wind direction, you see, can change very quickly when wind speed is very low, okay. What it really means in terms of the problem, see here, suppose you had some emission or some kind of accident, so the pollutants will be emitted, and then the pollutants will travel, because the direction is changing, they travel like this, and then direction is changing, they travel like this, and then again direction is changing, they travel like this, and something like this. So this will be the path of the pollutants as they will travel. Suppose if I had my conditions were not calm, same kind of city, well, if I could draw it exactly, and you had the same location here, okay, and there was a then suppose this was the calm conditions, calm, no calm condition, means wind speed is high, and then it means it will have a definite wind direction and the pollutants will travel like this, okay. So it means the pollutants will just travel in this area because the direction of the wind is constant, okay. And you see here, when you have the calm condition, how much problematic and how much large area as the wind tend to meander and travel all the way through from one direction to another, and then as a result you see the population that might be affected because the pollution is large number of people that might be affected, okay. And whereas this situation only a narrow band of the pollutants will be there and only small area could possibly be affected, okay. This is the advantage and disadvantage of the calm conditions, or the advantage of not having calm conditions, and but the problem of the calm conditions. So while planning an industry, while making some considerations, people should always think at what percentage of the time the wind is calm conditions, okay. So this gives you the concept of the calm conditions, and now we will move on to the next slide, where I am showing you the actual data that has been recorded using the anemometer and the wind vane. And then you can see here what are the data that we get is that suppose in the year 2007 month, that's month number 3 is March, date 1st March, okay, and the hour starting from the night time, okay. This is 1 o'clock in the morning, 2 o'clock in the morning. The direction is always measured in the degrees, okay. The direction was 96 degrees, 12 degrees, 274 degrees and things like that. And speed was, you can see here, is 0.3, 0.7, 0.8. So what you can, the interesting thing is that this is calm condition, okay. So much we talked about calm. This is okay, this is more than 0.5, so this is not calm. Let's see if you encounter any wind speed. See, again the situation here is the calm conditions, okay, or maybe there was some problem with the instrument, we don't know, that we need to see, but certainly the data is screened and shown. It means this is my period which is calm, okay. Normally the calm conditions are mostly in the night time, winter conditions, but these results are showing that even in the daytime the conditions were calm in the day hour. Anyway, as far as the concept is there, you understand where the calm conditions are there, and this also the most of the stations where you measure the wind speed and wind direction, you also measure the precipitation or rainfall, in this case rainfall. In fact, I can share with you this data is from Kanpur for a station for the wind measurement station installed at IIT Kanpur. Now the question is, the interesting thing, of course, the data is there, but you will find that the amount of the data is enormous. I mean, suppose if I have to look at the data of 1 year from Kanpur, this will be like, I don't know, 365 and 24 if I am just going hour by hour, that many data points I will have. And to make the sense out of such a huge data set is very difficult. So what the meteorologists and scientists have come up is a method as to how we can summarize the information, so that the useful, meaningful things can be abstracted or extracted rather from the wind measurements that we have done. So what is that done is normally what we plot or what we develop. Nowadays the computer will do, but what we develop is the frequency distribution, and here in fact we should call it joint frequency. Okay. What I mean by the joint frequency is, on this direction, you can see my arrow, I am plotting the wind direction. Same, recall the directions we measured as north, northeast, northeast. So here we are measuring we are indicating the wind direction, and this side what I did, the wind speed I have classified, okay, in different groups. Okay. Group number 1, 0.5 to 1, 1 to 2.1, 2.1 to 3, and so on so forth. Okay. And what will be my count when the wind direction is wind speed is less than 0.5 meters per second? I will count that as the calm conditions and put somewhere here, if I can show you. Yes, here it is, the calm conditions. Okay. So here what we have done is that this is the data for March 1st to 15, okay, and we are doing the hourly analysis of the data. So you can think of something, it will be something close to 15 into 24 observations, something, yeah, this will be close to 345 total observation. So what we have done here is that for every wind direction we have seen how many times the wind was in a particular speed category. So suppose my wind direction was north, and how many hours, okay, the wind was in the speed range of 0.5 to 1. So it was only 1 hour when the wind speed was between 0.5 and 1 and wind direction was north. So let us take an arbitrary example. Let us take this, pick up this number 8. Okay. What it means, it was, there were total 8 hours in such a way that, go back to this. Okay. What we will do here is that we will see here what this 8 really represent. 8 shows the wind direction when wind was from south southwest. There were 8 hours when wind speed was 1 to 2.1 meters per second. Okay. So this is how many data points I had, 345 data points, but I have converted this into some kind of table. Okay. So now our job is still not done. Okay. As to we need to say, as to represent some graphical form as we can. So we would like to present some kind of graphical presentation, and we try to make sense of the data. So let's go. We can also see here that that significantly high number, 44% the time the wind was calm. So now the thing is as to how we can plot this information. So these number of hours are converted to percentage now, or it's not quite percentage, it's a fraction. Okay, it's a fraction basically. So for example, if I go back, so this was the 8. How much percentage of this condition existed? 8 divided by 345. Okay, so that number will be equal to south southwest. Okay, and this one. Okay, clear? Now what I have done is I have converted, if I multiply these numbers in the table by multiply by 100, then I will get the percentages. So for example, what I have done in the next slide is taken the wind direction northeast. Okay, let's go back, northeast, and took this data. lifted this data from this table, these data, okay, and multiplied by 100 and rewrite them. So it means out of all the hours that is my consideration, 2.9% of the time the wind direction was this and the wind speed was this. Okay. So this is what is joint frequency. Joint means this as well as this. Okay, that's what we call as joint. So you can say, well, 3.8% of the time my wind was from the direction northeast and it was in the wind speed range of 1 to 2.1 meters per second, so and so forth. Okay. So now interesting thing is I must be able to plot it, and then how do I plot really is, I'll show you for this example. So my northeast direction is this, okay, because that's what I want to plot. So let me write this as northeast. Okay. Now remember the calm conditions. Calm conditions of 44%. So calm conditions have no wind direction, as we said. Okay, because wind direction is changing very quickly. So first thing what we do is we make a circle and right here, I should have this line. Anyway, we'll see it in a moment. 44%. It means that was my calm condition, and now I am plotting my data to form a windrose in the northeast direction. Okay, this is my direction. Now I go onto this scale and produce 2.9%. I can make a scale of this one, and then okay, this is what is my 2.9%. Okay. The next wind class, okay, let's give it a little different color, or sorry, we can't give the different color, but let's make it a little differently. 3.8% time the wind speed was 1.0 to 2.1, so this little bigger. Okay, then I can make it another block. Okay, so this is what is my 3.8. Okay, this one was at 2.9. Okay, after that again some little I'll remove this. After this again there's some little 0.6%, so little strip of 0.6%. Okay, then there's no 0 0 0, I don't plot, and then again 0.3, so I can go here little bit 0.3%, and then again 0.3. So this I showed an example only for one wind direction. Okay, so if we take all the data, we can represent all our wind in this way for all wind directions. This is very simple and very interesting, and we will show you the final results in the next slide, and it will look very colorful and very useful thing to show. Okay, what you see here is in the center the calm conditions, and this is what is now we have plotted in various directions what percentage of time the wind was. So we have kind of shown here as to this is what I had shown you in my earlier, this we plotted ourselves. Okay, this one, and the last thing, you can see here last thing we plotted this actually, but the computer plot will look like this. So similarly I can plot all the wind along all the wind direction, what has been the percentage of the wind speed that has been there, and then we provide a legend here. You can see here what wind speed. We also provide information on the calm conditions. Okay, and we also provide the resultant vector. So overall what has been the predominant wind direction, if you like, that has been 342 degrees, as you can see here. So all the information that we collected from our machines are finally put into this particular way, and then we can learn a lot from this windrose that we have plotted. And what is this called as? Oh, I should have told you before actually. These are called windrose. Okay. So let's see what we want to say. What does windrose conveys? Okay. So I'll quickly write. Okay. Now you understand about the windrose. It conveys calm conditions percentage. Very important thing. It also tells you what are prevalent wind directions. It also tells you what are the maximum wind speed. Let me write that as WS. That is, I can use this word, encountered. Okay, very interesting thing, and this information can help you locate or cite industry, or if there is industry, you can cite your residential colony. Okay, very useful thing it gives. Okay, and then suppose the conditions are calm, then you don't want to have industry there where the conditions are very calm, because if there is some problem, then pollutants will not disperse properly. Okay, so you have seen how useful are the windroses. You can plot the windrose for the 1 month, you can plot it for 6 months, you can plot it for various seasons, you can plot it for the entire year, you can plot it for a decade, you can even see if there is a change in the trend, if the wind direction is changing from year to year, or over the decade suddenly there has been change in the wind direction or the wind speed, and that can be very, very useful information, not only for the pollution control or pollution planning, but it can be useful for the other studies also. In addition to windrose, we also the pollution control engineers, pollution control scientists, we also make something which what you call as the pollution rose. That is in fact even more interesting. Okay, idea is simple. Okay, similarly as we did for the windrose, we take onto this side as the wind direction, as we had done for the windrose. Okay, and this side we take the concentration ranges. Of any pollutant, concentration ranges. See, you will recall that here last time what we took the wind speed ranges, but we can say about the concentration ranges. So suppose this is my direction north, let us say make the things a little simpler, northeast, and then this side I can take the wind the concentration, let us say between 5 to 10, let us say 10 to 20, 20 to 40, 40 to 100, and more than 100. So these are my concentration rate, and then I am looking for certain month, for example. So how many hours my concentration when the wind was from north, how much time, how many times the concentration range was between 5 to 10. So let us say I said there were the 5 hours were in this range, and there were around let us say 7 hours were in this range, and and when the wind is blowing north, don't forget about that we are talking about the windrose at north. So the concentration range was between 20 to 40, let's say it was 20 hours, and then this is again 5 hours and 2 hours. And then once we have this thing, we can exactly plot the way we plotted for the windrose, and then I'll show you an actual figure which has really been drawn for the Kanpur region. In fact, this you see the windrose pollution rose here, okay, and this is Taj Mahal, actually Taj Mahal, and then the actual measurements were done and then data were plotted, okay, to show the pollution rose. Okay, here the things here, legend you are seeing here is not the speed but the concentration ranges. This is the legend here, okay, and then you can very quickly say that, well, the most of the pollution to Taj Mahal is coming from this area because the wind is coming like this, okay, and this area is probably the pollution is reaching Taj Mahal from this area, and you can say almost from this area there is no pollution, okay, because most of the it is indicating that when the direction is like this, most of the pollutants are brought to Taj Mahal. So, what an important decision making assistance help we can get from the pollution rose. So, it may be the whatever now what you can do is you can identify the sources here and do the pollution control. Similarly, you can also say, well, there is nothing, even if there is a source here, let us say pollution source, this is not causing, so you can take the decision here. So, maybe whatever there may be factories or there may be industries or there may be some big source here, for example, or so the pollutants may be coming from long distance, okay, that need to be seen, but the pollution rose will tell you lot many things. And then let me share, this is the actual data taken from a site, and then you can see that how useful the pollution control decisions can be taken just based on simple graphical output that we can generate with very little efforts. So, importance of pollution rose, it tells you what direction from where pollution is coming, and not only the direction, to what an extent the impact is you can, it can help identify the sources which may impact site or location of interest, okay, and you can even plan a pollution control which can be season specific, because you see the wind direction change from one season to season, and so will the impact of sources will also change. In winter, the most of the pollutant may come from north, and in south it may come from the east. So, you can say, well, all right, when there is summer, the pollution sources must be effective from the pollutants which are generated from south. So, this way you can make very useful decision and can contribute to the pollution control.